What about the case where the two substituents on the cyclohexane ring are different from each other, and one of those substituents is very large? This example has a cis-1,4 disubstitution, and from this we know that it doesn't matter what chair conformation we look at. One of the substituents will be in the axial position and the other will be in the equatorial position. Our substituents here are a t-Butyl group and a bromo group. The bromo group is in the axial position, whilst the t-Butyl group is in the equatorial position. Let's identify any significant steric interactions in this conformation. We have no gauche interactions, but we do have two 1,3 diaxial interactions between a hydrogen and a bromo group. Each of those interactions contributes 1 kilojoule per mole to give a grand total of energy caused by steric interactions in this conformation of 2 kilojoules per mole. We're going to take the chair and ring flip it to provide the alternative chair conformation. What's changed here? Well, now it's the t-Butyl group that's in the axial position and the bromo group that's in the equatorial position. And this has a very significant impact upon the energy produced by steric interactions in this conformation. Nothing's changed in terms of gauche interactions. There's still no gauche interactions. But we now have two 1,3 diaxial interactions between a hydrogen and a t-Butyl group. Each such interaction contributes 11.4 kilojoules per mole to give us a grand total of 22.8 kilojoules per mole. There is a difference in energy between the two chair conformations here of 20.8 kilojoules per mole. This is a massive difference. The 1,3 diaxial interaction between a hydrogen and a bromo group is much smaller in energy than the 1,3 diaxial interaction between a hydrogen and a t-Butyl group. The consequence of this is what we describe as the locking of the ring. We can't have a t-Butyl group in an axial position, as that chair conformation would be too high in energy. So the t-Butyl group must be in an equatorial position, and there's only one of the two possible chair conformations where this can occur. So that chair is locked.